Hello everyone. This lesson we're going to discuss when a three-phase forward Y system. So this time the system with a neutral, we develop an open on the line or on the low. What's going to happen? So this time the drawing is we have three resistors connected in Y, but the neutral is in the system. So we have a neutral conductor down here. The supply is still 120 208 volts, three-phase, forward, and each low is 10 ohm resistor. Working under normal condition, still line voltage 208, phase voltage 120, phase current gonna be phase voltage divided by the resistance. I got 12 amps, line current the same as phase current, 12 amps, total power, nothing changed, that's a normal condition. Under normal condition, even we have a neutral conductor down there, because it's totally balanced load, each phase have the same impedance and the same power factor, so the neutral carry zero current. Now we're going to have an open line situation happen, which is a line open down here, or we're going to have an open load situation, one of the loads open. When those kind of situation happens, we can draw the equivalent circuit. We still have between B and C, that two line work, but because the original neutral conductor in there, in this case, this neutral become the common conductor. It's not neutral anymore because we lost one of the line down there. It's not three-phase anymore. But it's not also a single phase because we have the neutral down there. The neutral gonna keep the voltage and the current balance in there. Now let's do the calculation. The line voltage is still 208 volts. The phase voltage is 120 volts. So I can calculate phase B current. Because there is common conductor in here, it's the originally neutral, I still will have 120 volts cross from that phase. That's where this conductor does here. So when I keep 120 volts down there, 10 ohms, I have 12 amp. For phase B is 240 degree. So this current is at 12 amp, 240 degree. Phase C, I will have a current about 12 amp and 120 degree. Now the common conductor, the current goes through the common conductor, gonna equal to the phase B current plus the phase C current. Those are all vectors. We add them together. The common conductor gonna carry 12 amp and 180 degree. So you can see the common conductor is carrying the same amount of current as the line conductor. They all have 12 amp, but they have different degree. We calculated the power. Now we only have two phases in there. These two phases each gonna develop as power. The power we calculate by using volts times amp. Now we have a total power development circuit with 2880 watts. Compare this 2880 watts to the normal condition 4320 watts. We can see because we only have two load work, so they develop about 2/3 of the original power, or we can call they have 66.7% of the original power. If you remember last lesson, we have a single phase situation, we only have 50% power, but when we have the neutral down there, we will have 2/3 of 66.7% power. This diagram you should be getting pretty familiar with. It's called a wheel of the current. So because the line A is open or low A is open, there's no current goes through here, but the line B and the line C, we still have a current down there. The common conductor gonna carry a current equal to line B and the line C, but in a different direction. So here's our three vector down here. You can use two ways. We can do the vector calculation, or we can see on this diagram what's going to happen to the common conductor current. If you have any question, you can send us email or chat with us online.